Hey guys, Mr. B here, again making another lovely math video while my little baby sleeps away. Well, he's not so little, almost 3. So I'm going to give you guys a difficult absolute value limit. So this is an example that I've seen on some calculus exams and I've used myself from time to time. One where you have two absolute values in the same question. So again, we have to decide whether or not how we're going to deal with this thing with the absolute value symbols. So again, we have to make this, we have to make a piecewise function of this absolute value. So again, absolute value can be broken up into what's inside the absolute value and then the negative of what's inside the absolute value. And then for something that has a positive slope, you keep the right side, or the positive side, it's greater than 0. And then the left side of it is going to be the less than 0 part. So that's important to be able to do, to be able to write this piecewise absolute value function for any given function. So if you're looking for an example of something like that, you might want to just go back and check out some of my other videos. And then after this one, I'm going to make I'm just going to do this example in this video. So if you want to see another hard example, I guess I should just have example. If you want to see another hard example, you can go back and check it out. Alright, so the other thing we have to recognize is that this doesn't have a side designated to it, so it's actually to 0. So when examining limits of absolute value functions, we have to examine both sides of the actual function. So we want to look at the left side and then we want to look at the right side. So let's go ahead now and actually just look at the left side first. So the limit as x goes to 0 from the left side, so we use a little negative to represent that. So when we use the left side, so this really right here, guys, is the left side. And this is the right side. So each side has its individual function that represents it. So the left side is represented by the negative x. So what we can do is, instead of writing an absolute value of x, we can write that particular function. And then 2x subtract negative x. We got to be careful about the signs here on the bottom. So then we'll go ahead now and simplify this. I don't know why I wrote that equal sign there. And then so that's just going to be 4x, and that's 3x subtract x, so that's just, or 2x subtract 3x, not 2x subtract a negative x, which is 3x. I want to get the answer root. So then these can cancel, and then all you're left with is 4 over 3, so that's our actual limit right there. Okay, so now we'll do the exact same thing, and we'll just examine it from the plus side. So that's the right side, so the part that's greater than 0. So that's this guy. So if I take it from the right side, I get left with x plus 5x all over 2x minus x. So I just take the positive of it. So I get left with the limit as x goes to 0 from the right side. So then top that's 6x. On the bottom that's just x. So these guys cancel. So I get left with 6. So if you remember your basic definitions of limits, is that in order for a limit to exist, we have to approach the same number from both sides. So the one-sided limits have to be the same. So if you look at this, these are obviously not the same. So we can say because the one-sided limits are not equal. So because the one-sided limits are not equal, the limit as x goes to 0, and we can rewrite absolute value of x plus 5x all over 2x minus root x, does not exist. Alright, so that's a harder example, guys, where you have two absolute values in one question. So I hope this helps you in your quest to conquer calculus. And keep up the hard work, guys. I really appreciate it, as always. Thanks for watching, and I'll see you guys in class.